Okay, in this video, I'm going to demonstrate how I can run a regression in the R package. So in the last video I uploaded, we looked at how to read in data and we looked at how to start visualizing and interrogating that data. If I remember rightly, we looked at time series last time. This time I'm going to change tack and look at some cross-section data. In fact, let me show you the data. I have salary in thousands for 50 individuals. I have, sorry, 100 individuals. R will only show me the first 50 here. Years of education, years of on-the-job experience, and I have an indicator variable for gender. So let me import the data set, and it's come in here. Now, there are two things I want to do. I want to tidy up this rather unfriendly name, which I might have to type out a few times. Also, just to be on the safe side, I am going to make sure it's a data frame as well. So I'll make an object called wages, and I'll use the as.data.frame argument and just apply it to that. So now I have an object with a neater name, and I know for sure it is a data frame. If I actually need to check the class of something, I can use the class argument just to prove it is a data frame. Now that the housekeeping is out of the way, I can actually start the process of running the regression here. In R, the base command for a linear regression is LM, linear multiple, set of brackets. I'll have the Y variable, a title, and I start listing the X variables off. Rather unusually in R, you don't separate them with commas, we separate them with plus signs. Just a word to the wise, by default, R will include a constant in your regression. If you do not wish the constant to appear, you'll end the syntax with a -1. Now, when I run a regression, I'm actually going to create an object to store the results of that regression. So since this is the first regression I'm running, I'll just call it LM1. You call it what you like, LM. Now I need to decide what's my explained variable. What's the Y variable? Now, if you want to follow along intently, pause the video, work out what explains what. I'm going to say that salary is the explained variable. So I'm going to reference salary in the data frame in the usual way, and I'll use the other three variables as explanatory. Wages, education. Doesn't really matter which order I put them in. Experience. See, I'm being a bit careful to use the autocomplete. Now, I nearly made a silly mistake by putting commas instead of plus signs, because in R, it's quite usual to separate things with commas, but in this case, it has to be plus signs. So I caught my error before I actually pressed enter. If you do run it with an error, you'll get a load of red text and you need to go back and look at it. So if I press enter, that should create a new object up here. It doesn't show me anything, but if I just key LM1 return, I get to see the equation that I've run. I get to see the constant term, and I get to see the beta coefficients. Now, that's enough for me to actually just interpret the model. That will get me sign and size, but if I'm an economist or an econometrician who's actually worth my salt, I'll at least need to do t-tests and an f-test before I can even start thinking about testing for multicollinearity, autocorrelation, and heteroscedasticity. So if I do summary LM1, and incidentally, this is the reason I actually named it, I'll now get a bit more to look at. So I'll get the same here. I get a t-value for each of the coefficients. I get an associated p-value if I prefer to do the p-value tests. I get my r-square toward the bottom, and I get the f-stat toward the bottom too. This is the basic principle to run a linear multiple regression. Of course, we can do single regression in the same way. I think this is enough for one video. I think either the next video will look at autoregressive structures, or the next video will look at hypothesis testing. But for now, let's leave it there.